Hello everybody and welcome back. We're looking at question 5 on the 2005 Euclid contest. So, a goat starts at the origin, 0, 0, and then makes several moves. Wasn't there a goat question recently? I think the 2003 paper had a goat as well. A goat that was staring at a helicopter, I think. Or maybe it was staring at a plane, I don't remember. So it makes several moves. On move 1, it travels 1 unit up to 0, 1. On move 2, it travels 2 units right to 2, 1. On move 3, it travels 3 units down. So it's sort of making a big spiral. On move 4, it travels 4 units to -2, -2. It continues in this fashion so that on move n, it turns 90 degrees clockwise, and then from its previous heading, and travels n units in the new direction. After n moves, the goat has traveled a total of 55 units. Determine the coordinates of its position at this time. Okay. So, after n moves, after move n, the goat has gone, or has moved 1 unit, then plus 2 units for the second move, plus 3, and so on all the way to plus n. But there's a formula for this. N times n plus 1 all over 2. It's a fantastic formula. I've explained it in some videos. I'll probably continue to explain it every once in a while, but I think this time I'm going to skip over it. But it's great. It's got sort of a nice little geometric proof. There's lots of fun stuff you can do with this. These are what we call triangular numbers. But I'm not going to dwell on that. So this is the total number of moves the goat has gone. So after move n, we're told that he's gone 55. So that means 110 is n times n plus 1. Now you could expand this and do a quadratic, or you could just say we need two numbers, and we need one number when I add one to it multiplies to give me 110. It's going to be pretty quick that n is 10. Okay, 10 times 11 is 110. And if you wanted to, of course, expand it out quadratic, but I would say this part here is clear. Clearly n is equal to 10. So the goat has done 10 moves. Now it's up to us to understand the coordinates. So the goat starts at 0, 0 and goes up by 1, then over by 2, then down by 3, then over by 4, and then up by 5. So he's making a big spiral, and you can, 10 is not that much. You could probably graph it a little bit or convince yourself or figure out the coordinates at each step, but I'm going to show you a little something different. Take a look at the even moves. What do they do? So here we added 2 to the x-coordinate. Here we subtracted 4. Here we added 6. Down here at the 8, we would subtract 8, and then for the 10, we would add 10. So we can figure out where the x-coordinate is going to wind up without having to figure out each individual coordinate along the way. Same with the y-coordinate. It's determined by the odds. So we go up by 1, then down by 3, and you can check. After the third move, the coordinates were 2, -2. Next, the y-coordinate would change with the plus 5 over here, and so on. So x-coordinate is going to be 2 minus 4 plus 6 minus 8 plus 10. Difference of 2, so it's going to be 6. The y-coordinate is going to be 1 minus 3 plus 5 minus 7 plus 9. We don't do 11 because we haven't gone 11 moves yet. Difference of 2. It's going to be 5. And the goat is at 6, 5 after n equals 10 moves. Okay? So there we go. That does it for A part, but we just needed our final answer for that one. It's B that requires some written stuff. Alright, B. Determine all possible values of R such that the three-term geometric sequence 4r squared is also an arithmetic sequence. So the difference between these two, two consecutive terms is the same. Okay. So we've got 4r squared. So to be arithmetic, we must have a common difference. So that tells me 4r minus r, the difference between the first two terms, has got to be the same as the difference between the next two terms. Alright, well this is a quadratic in r, so let's first let's divide through by r, or by 4, and we'll get r squared minus r. Now let's bring the r minus 1 over to the other side. 0 is r squared minus 2r plus 1. And this is more readily recognized as r minus 1 squared. So if we want this to be equal to 0, r has got to be 1. Pretty anticlimactic, but we've explained everything. If you got to be an arithmetic sequence, you have to have the common difference. Common difference very quickly leads to this setup, and there's only one solution here to give us 0. R equals 1. We should probably put a final little statement there, but is that all we were asked for? Determine all possible values. And then they just explain what an arithmetic sequence is. Okay. So r equals 4 is the only... this is called an arithmetic code geometric sequence, something to that effect. Yields the only sequence for 4r squared equals 4 that is also arithmetic. That actually went by pretty quickly considering how long the goat part took. I'm sure I'm not missing anything. That doesn't seem too simple. All values of r such that the three-term geometric sequence is also an arithmetic sequence. No, that's it. There's nothing we can do. There was only the one solution. Okay. So that does it for question 5. And quite a jump down the page, but that's okay. Probably because these diagrams are so big. Question 6 is up next, so we'll take a look at that together. Join me in the next video.